Good morning to one and all. Am I audible to everyone?
Yes, sir. Yes, sir.
Yeah, thank you. A very good morning to one and all. It gives me immense pleasure to welcome you all for a faculty development program on research in mathematics in collaboration with Pi Mathematics Association, Chennai, organized by the Department of Mathematics, Little Flower Degree College, Uppal, Hyderabad. This is M. Prashant, Head Department of Mathematics. He is your host for today's session. So, famous quotations for mathematics. Mathematics is a great motivator for all humans because its careers start with zero and never end like infinity. And a famous quotation by Srinivasa Ramanujan, an equation means nothing to me unless it expresses a thought of God. From the structure of buildings to the discovery of new planets, from trade to fashion and new technologies, mathematics serves as an important tool in the advancement of science and technology in fields as engineering, biology, philosophy, and arts. And it is also present in nature, concealing and revealing its charms in various forms, integrating research. I take this opportunity to welcome our principal, Reverend Brother Vincent Reddy, our vice principal, Mrs. Jayanti Reddy, esteemed staff, participants from different institutions across the India, and my dear students. Now, I would like to introduce our college to you, Little Flower Degree College, located Uppal in Hyderabad, Telangana State, a Catholic minority institution established by Montfort Brothers of St. Gabriel's. It was started in 2008 as a part of Little Flower Junior College, Hyderabad. Now, I request our technical team, Mr. Raman sir and Vijay sir, to take a virtual tour of our college.
Sivaraman Degree College, Uppal, Hyderabad, a Montfortian institute run by the Brothers of St. Gabriel Educational Society, has been illuminating the world around with its motto, Lead to Illuminate. In its 12 years journey of excellence, LFDC has been fostering the young generation to be humane and preparing them to compete, realizing their dreams and purpose in life on the competitive global platform.
Good educational environments, discipline.
Practical skills helped me in getting my first job.
Excellent placement opportunities.
LFDC is an awesome college.
Dear parents and students, Little Flower Degree College Uppal, Hyderabad has begun its admissions for the academic year 2020 and 21. The online application for the 3-year degree in BA, BSc, BCom and BBA is now available on our website.
Little Flower.
Little Flower.
Little Flower College.
LFDC.
LFDC, Little Flower Degree College.
Thank you, sir. Now, I request my colleague, Mrs. Swapna, to introduce our eminent speaker of the day, Dr. R. Sivaraman, sir. Over to Swapna.
Good morning, sir. I'm audible.
Good morning, ma'am. Audible, ma'am.
Yeah. Good morning, everyone. Good morning, everyone. It's my immense pleasure to introduce today's speaker, Dr. R. Sivaraman. Dr. R. Sivaraman, currently working as Associate Professor of Mathematics in DG Vaishnav College, Arambakam, Chennai, has more than 20 years of teaching experience. His areas of interest are number theory, real analysis, and applied mathematics. He has presented more than 40 research papers in various international journals. He has successfully guided 6 MPhil students. He is a reviewer member of editorial board for 10 international UGC approved journals. He is a resource person for training teachers appointed by Teacher Recruitment Board, RMSN SSA. He has conferred with Honorary Doctor of Letters from California Public University, America. Honorary Doctor of Science from University Swahili, Republic of Panama, Central America. National Award for Popularizing Mathematics Among Masses in 2016 by Department of Science and Technology by the Government of India. He was also conferred with the prestigious Indian National Science Academy Teaching Award for the year 2018. This award is the greatest recognition for a teacher working in college or university throughout India. He has also received Abdul Kalam Teaching Excellence Award in 2015 and Abdul Kalam Scientific Excellence Award in 2017. He has also received 2 state government Best Book Awards in science for consecutive years 2011 and 12. Overall, he was conferred with more than 20 prestigious awards for his contributions in mathematics. He has given more than 300 lectures many prestigious mathematical organizations like American Mathematical Society, London Mathematical Society, Indian Mathematical Society, Ramanujan Mathematical Society, and Mathematics Teachers Association. He is also a member of Ramanujan Encyclopedia. He was also a member of team appointed by State Government School Education Tamil Nadu for preparing mathematical models in 2008. He was a chairperson the 10th class new mathematics textbook released in June 2019. He writes regular articles and puzzles for many famous newspapers. His articles were also published in monthly magazines like Chutti Vikatan, Manjari, Chennai Report, Arambu, etc. He is a founder, trustee of Pi Mathematics Association and academic secretary of Association of Mathematics Teachers of India. He is currently the editor of the journal Junior Mathematician, a quarterly magazine for school students published by AMTI. Spreading mathematics among everyone is his vision. Little Flower welcomes you to this webinar, sir. Over to Prashant, sir.
Thank you, ma'am, for a nice introduction of Dr. R. Sivaraman, sir. A small announcement to all participants. Please post your questions in the chat box, which will be addressed at the end of the session. Again, I'm announcing the small announcement to all participants. Please post your queries and questions in the chat box, which will be addressed at the end of the session. Over to Dr. R. Sivaraman, sir.
Good morning to all. I mean, audible.
Yeah, audible, sir. Audible, sir. Good morning, sir.
Okay. So, good morning, friends and research scholars and students. I take this as a very good opportunity for me to address before you today. The point now, for the last decade, beginning from I think 2009, for the last 10 years or so, the University Grants Commission, shortly called UGC, has made this research aspect in any subject, not only in mathematics, mandatory for allowing many people to join as assistant professor in government colleges or even in self-financing colleges today they require this kind of PhDs. So if you want to pursue a PhD, you need to do some good research. So research has become mandatory for the last 10 years or so. It was not so when we did our research some 15 or 20 years ago. So the whole process now comes to people, young students and research scholars who doesn't know the way to perform research. So this kind of programs, webinars and other seminars will help you to understand what a research should be and how do you want to pursue your research properly. So though it is not possible to convey everything what we understand through research process, we try our best to convey whatever possible in the short time possible. And if you have some other doubts or anything, I can render my email ID so that you can contact me later. I will do possible help to you and in all means. The idea now to do research in mathematics, see, if you compare mathematics with other subjects, it's a very vast difference because in other subjects you have laboratories to go and actually test your hypothesis, but in mathematics it is not so. But the advantage in mathematics is you don't require any infrastructure. You can just think over in your mind. All you need at the most is a pencil or pen and a paper to just scribble and verify your results. So this is all. Even sometimes if you're a very experienced researcher, you don't even require those materials. You just think about some concept in your mind. If you travel along, I have been experiencing, well, I travel through bike or through a train journey. I had come up with an idea and I come to my place and just write it down and it comes out to a research paper. So that is how, if you're a little bit experienced, you come to have this kind of idea to do research. But anyway, for young students who want to pursue research at the beginning level, I just propose three things. See, there are three basic aspects to begin a research. One thing is to read the literature. The first step in doing research is reading the literature. Of course, each one of us will have our own specific liking in the subject. When you pursue your BSc or MSc course in mathematics, you will, some of them would be liking geometry, some of them would be liking numbers, some of them would be liking calculus, some of them would be liking mechanics. So each one of us would be liking something in our mind, and we feel that we are quite comfortable with understanding that particular idea compared to other idea. Doesn't mean that we don't understand the others, but you have more inclination to study those particular thing in your mind compared to the other ideas. So if you feel that you are good in particular aspect, as I told you, like in dynamics, for example, or in calculus or something, you just choose ideas in that thing and then see research papers. So first thing is to read the literature, collect all possible literature, and then gather all possible information. That's the first thing that you have to do as a researcher. The first step in doing research is to read vastly the available literature. Now you are living in a period where you have more open access to everything. Like in previous years, even if you want to go to verify a paper or see a book, it takes long time. Now everything comes very easily. Even if you want to get a book, you can just order online and get it. So it's not going to be very big challenge or problem for you. So what I would suggest you is to, the first step for doing research is to select a corresponding topic of your choice, of your liking, and then opt for reading the literature vastly. Supposing if I am interested in number theory, I want to know what kind of research is going on currently, and what efforts have been done previously, what kind of problems has been solved and what kind of problems have been unsolved, and what challenges are facing us. So this is what I need to know before I start doing research. This will probably take you from 6 months to 1 year time. If you do correctly, it will easily consume 6 months to 1 year time. The second step is to, after reading the literature, there among many problems and many ideas left over, you can just pick two or three of your liking, which you feel that you can adapt to it and solve it or do something with it. You choose that kind of problems with you and ideas with you, and select a corresponding guide of your choice who might be, you think you might be helping you in all possible ways and guiding you with right ideas if you have any doubt in your work. So choose a corresponding person who might you feel feels comfortable to work with, and then depending on their guidance, you just select a problem, maybe one or two, and then solve. Now, my basic advice for anyone to do research now in current days, in current time, because it's need based now. In the previous years, the research work was like uh, uh, many things that people do research in 20 years ago or 30 years ago when they want to do. It is their choice. Research is not compulsory in those days. Teaching and research were quite different in previous years. My teachers, my own teachers who taught me BSc or MSc were not many, maybe one or two were only PhDs. Most of them were just MSc or MPhils, which means that research is completely different from teaching aspect. Even now, I feel that to become a good teacher, you not be a researcher. But what happened is that when you mix this research aspect with your teaching, you come to know more and more idea that will enhance your teaching. When you just focus on teaching, you just teach whatever you know year by year, year after year, the same thing. You get bored after some point of time. But when you do research, if you are a researcher as well as a teacher, doing more research and guiding people, you get new ideas one after the other that will enhance your own understanding, and your teaching will become polished. And you throw some new problems to students that you are facing every year. That will be a very good exercise for you as well as for the young students who pursue research or class under you. So this is one of the big advantage in mixing research with teaching. So in that aspect, I think research element is quite vital nowadays because it polishes our ideas. It helps us to see, I mean, think more. Just as a simple example of this, why we require research in teaching processes, because in today's pandemic COVID-19 problems, I saw many papers pouring out, giving mathematical schemes and models and ideas by various even research students from other universities in US and UK. They were not professional researchers. They were just students pursuing their MPhil degree or PhD degree. They had consulted with their corresponding guide and have done beautiful work in modeling the pandemic issues, which some of the papers recently I saw were of very good quality. In fact, they were very good. So the idea is that if you think properly, the kind of research will help you to even solve human issues like this pandemic. So mathematics goes a long way, and if you want to be a part of that history, you need to do good and active research. I think with this, I can just pass on to the third step in research is selecting a problem is the second step. Third step is to consume or devote yourself completely to solving the problem. As I told in the first step, you choose 2 or 3 problems with you. If you do not succeed in the first problem, choose the second problem. Sometimes what happens is unexpectedly you comes out with a very surprising result which you would not have expected in the first time. When you choose your problem, you could not have expected this kind of solution at all. That is very surprising aspect of doing research in mathematics. Very often people come to that surprise. Even I had experienced such things when I could have got some idea in my mind and I thought I could end up with this particular result when I finished the problem. But while pursuing the research, I found that the ideas got deviated and I end up surprisingly with quite unexpected result, which I never could have thought before. So this is what one thing that you can know. I had collected few areas of research and that students can pursue, and I have collected some links also. I think I can show my slide now. So, PPT. Sir, is it possible to share these slides?
You can share, sir.
Is the slides visible, sir?
Visible, sir. Visible,
Hello?
sir. Visible, sir. Visible, sir. Slides is visible, sir.
Are the slides visible?
Yes,
Visible,
yes,
sir.
sir. Yes, sir.
Visible, sir. Yes, sir.
So you see, there are 2 branches of mathematics. One is pure mathematics and other is applied mathematics. I had listed 8 topics in pure mathematics and I had listed 8 in applied mathematics. Of course, as you can see in the slides, algebra, algebraic geometry, analysis and differential equations, number theory, geometry, mathematical logic and foundations, topology and representation theory. There may be other choices also. See, these choices are not fixed. This may differ from person to person. But after a long time of thinking and practicing all these things for a long number of years, I thought to choose this idea, this 8 topics as one of my preferred ideas in pure mathematics. Of course, one can add few more to this. In applied mathematics, of course, you have combinatorics, probability and statistics, analysis and differential equations. That is again repetition there here. And financial mathematics, mathematical biology, scientific computing, mathematical physics, and miscellaneous research areas where you have plenty of other research aspects also, which I will share in later slides. I will explain a bit about each of the topics that I mentioned. In algebra, of course, you beginning with basic things like solving equations, in particular polynomial equations and other kind of equation like exponential equations. You can probably find plenty of ways, right from ancient Indian mathematicians had found to solve different varieties of algebraic equations. Now, when you talk about solving algebra equations, you know the algebra is science of solving equations and finding the unknowns involved in the process. Now, when you think of solving equation, system of equations or a single equation like a linear equation or a quadratic equation or a cubic equation, see for polynomials the process is quite straightforward. But if you go for higher degree equations, or like equations of the form like x e power x minus 1.4 is 0, or x sin x plus cos x is 0. If you want to solve this kind of equations, it's not so easy to locate the real number root, and even if we are not sure whether such an equation will possessing factor root. So anyway, I will, for your reference, I will provide this PowerPoint to the college, Little Flower College. You can get from them after my presentation. So don't worry to copy down all this materials right now. Just listen to it. The higher side of algebra begins with group theory and it extends to ring theory, and it goes to fields, vector algebra. Then you have linear algebra, where you discuss all kind of transformations from one plane to other plane and all those things. And linear algebra and the ideas of groups particularly found its way in application of atomic physics, where people like Einstein and others have worked out. In fact, I can share an information that one of the equations that Ramanujan wrote in this work called Ramanujan summation, like 1 plus 2 plus up to infinity is minus 1 over 12, minus 1 by 12. This work was one of the equations that Ramanujan wrote coming under the name Ramanujan summation. This was found some years back by atomic physicists, and they found that this equation has connection to what is called string theory in physics. And people are coming out with new connections of what Ramanujan wrote in his notebooks. So that is one of the very surprising aspects that we see in mathematics. Not only with Ramanujan's work, but we come under new discoveries with Euler's work, Lagrange, Hamilton, and so many other mathematicians of yesteryears. Now, linear algebra had been applied to electric circuits, various electric circuit problems. I remember taking a class to EEE students, electronics and electrical engineering students, who had who required the need of solving mathematical equations. Particularly, they need algebra in a very good way to solve all kind of equations using matrices and also other objects. So this kind of ideas that we have here in groups, rings, fields, and basic ideas of solving techniques, solving equations, has been a tool to understand the structure of a universe on a whole. This is what physicists think now. The second research topic in pure mathematics is called algebraic geometry. So of course, this topic, algebraic geometry, is not very old like algebra or number or something. Algebraic geometry is a very difficult idea in the sense that it mixes everything like analysis, topology, geometry. It's interconnection between all those things, but it mainly concerned with study of structures and identifying one idea with other. As I have written here, you see, algebraic geometry uses diverse methods with input from commutative algebra, partial differential equations, algebraic topology, which is a higher version of topology, and complex and arithmetic geometry. This is mixture of complex numbers and geometry, among several other ideas. So mathematicians use algebraic geometry to study cohomology and geometry of moduli space. What is the need of doing all these things, like studying cohomology and moduli spaces of curves? And see, the main aspect in doing research in mathematics is to identify two things. Now I have two objects with me, say A and B. I know the properties of A, but I do not know the properties of B that much. So if you, through some way, through using algebraic geometry or topology or through some other idea, establish equivalence between these two objects like A and B, since I know the properties of A, I expect the same kind of properties to be hold true for B also. So this is one kind of knowing unknown through known objects is a basic idea that all these research areas will carry out. And that is a basic thing that mathematicians were working on. Okay, so this is the main problem and the focus of all these research areas, particularly like topics like algebraic geometry and algebra. Third, pure mathematics ideas, analysis and differential equations. Now you see, research in analysis can be carried out in two different aspects. One, you can perform research in real function through real function, what is called real function theory, and of course you can go for discussing properties of complex functions, complex valued function, that is complex function theory. And there are huge number of papers and literature available in these two aspects. There are many mathematicians both from India as well as from other countries, Asian countries as well as European countries, who were working on real and complex function theory. So there are plenty of information available in this. You can probably define some new operators. See, one thing that this idea of real functions and complex functions throws before you is to discuss kind of introducing new operators from which you can derive some specific properties of those operators and submit as a research work. Like you can, if you define a new function, like something that you like that comes to your mind, you can prove that it satisfies commutative property, it satisfies multiplicative property, which means uh, that f of a star b is f of a star f of b. This is called multiplicative property. Sometimes it might satisfy additive property also, which means f of a plus b is f of a plus f of b for two objects a and b under your function f. So this kind of properties that you can uh, deal with and see whether if you can apply this to some branch of engineering. So this kind of research is certainly possible if you have proper tools with you and spend some good time with it. And then differential equations have strong connections with geometry and applied mathematics. See, of course, many people know about this, and want to spend more time on it because all engineering faculty, students, and the faculty who teach engineering subject um, will know that if you want to study wave equations, heat equations, and study a propagation of waves, and there's a special research area itself devoted to this called wavelets and all those things, which involves partial differential equation in particular. So one-dimensional wave equation, two-dimensional wave equation. So just changing these parameters and changing the order or degree of equation, if you can come out with a new application, that will be a very interesting thing. And to aid your ideas and the inferences, there are so many softwares like Maple, Mathematica, MATLAB. You can make use of the softwares to program something and see whether you could come up with a new solution which adds more information than existing ideas. So that is one kind of possible thing that you can have. So this kind of approach will help you to present a research in a very good way, because understanding mathematics visually is what is need of the day, and that will clear many doubts among students as well as people who do research. Unlike algebraic geometry or pure algebra, where you don't have much possibility of doing things, your solutions, your proofs through visual way, this ideas like analysis and differential equations in particular will help you to view the ideas visually, and it helps you to make you feel how good your solutions. So you can use this programming languages or programs to run through your solution and see how effective they were. And the other good thing that in recent research areas in the last 50 years or so, it was very surprising that many branches, separate branches of mathematics got mingled with. That is one beautiful aspect of doing research. See, you find set theory mixing with algebra, algebra mixing with analysis, analysis mixing with topology, topology mixing with general spaces, what we call manifolds. I'll talk about that later. So after some point of time, if you do research for many years, after being a research mathematician for many years, you see everything to be same. There's no distinction. The distinction comes only at lower levels, but we are doing at higher level mathematics. Absolutely, there's no difference unless otherwise we name it for our identifying purpose. Okay? So that's one thing. So those who want to do uh, research in applied mathematics, take differential equation. That will be one of the best tool for you. Number theory, of course, number theory is my research area, and not many people probably knew that there are 6 sub branches in number theory itself, namely analytic number theory, algebraic number theory, Diophantine geometry, probabilistic number theory, arithmetic combinatorics, computational number theory. Now, to explain each one of these ideas, it will take some more time. So, because I need to specify something else also. So, if you want to do research only with numbers properties, like how many numbers of this kind are there and all those things, like what is today's date is 28, and if you take the divisors of 28 and take the reciprocals and add, so what could be the divisors of 28? 1 divides 28, 2 divides 28, 4 divides 28, 7 goes to 28, 14 goes to 28, and 28 of course divides 28 because any number divides itself. So if you take this divisors and take the reciprocals and add, like 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 7 plus 1 by 14 plus 1 by 28. If you add, you always get 2. In fact, there are special numbers called perfect numbers for which this property holds true. The first perfect number is 6 and the second perfect number is 28. So I thank the Little Flower College for choosing this particular date because 28 is the second perfect number. So I was quite happy to give my presentation on this day. It so happened that we were doing this on this particular day. And there are other properties also. There are so many good properties that 28 possesses. In fact, Ramanujan was hailed as a number friend while he was doing research in England by Littlewood. He said once that every positive integer seems to be one of his personal friend about Ramanujan. So that kind of affinity that Indians, usually Indians, have a good affinity towards number theory. And I have been seeing many good mathematicians in number theory from Andhra. Andhra Pradesh is very well known for producing great number theorists, right from Ramanujan's period till today. So most of the big people from Indian mathematics were from Andhra. So that's one thing that AP has been contributing continuously. So it's not quite wondering to me that people does good mathematics and particularly numbers in Andhra Pradesh. Now, if you want to discuss this kind of properties about numbers, why the sum of reciprocals of certain numbers is 2 and all those things, that comes under what is called analytic number theory, which involves both real numbers as well as complex numbers. Algebraic number theory is some kind of area where you mix algebra, like finding number of solutions in a particular field. If you want to solve an equation with respect to some modulo arithmetic, like mod 5, I need only mod 5 solutions or something. So if you want to go for solutions in varieties of ways, you discuss about what is called algebraic number theory, which mainly deals with solving special type of equations. Diophant geometry is one thing, that area of number theory beginning from the time of Diophant, ancient Greek mathematician of 2nd or 3rd century BCE. Now what he did was seeking solutions to equations in integers. So if you want to solve any equation whose solutions are always integer, then that type of analysis is called Diophant analysis or Diophant geometry, whatever you call. Probabilistic number theory, arithmetic combinatorics, computational number theory are all branches of mathematics. In particular, computational number theory involves mixing numbers with computer programs. The idea is like how many numbers of this kind will have. If it's not humanly possible to do this, you can make use of computers to conclude that this many numbers are there. The recent mathematicians actually knew. Hello.
Sir. Continue, sir.
Continue, sir.
Recent mathematicians probably knew that all great problems like Kepler's problem, which was unsolved for more than 350 years, were solved in the year 1998 by using computers. In particular, Thomas Hales from UCLA, University of California in Los Angeles, solved this famous Kepler's problem, which is about stacking fruits, orange fruits. So I had been given the screen to me. I don't know how to some screen. Yes. So there have been many great problems solved recently through computers, like four-color problems is another example in mathematics from graph theory, where Apple and Hacker, two mathematicians, or rather computer scientists from Apple company, solved in 1970s or late 1970s to get a solution by enumerating all possible graphs which only has four colors. So this kind of four-color problems involve solution, but there are few pure mathematicians who still does not accept that proof. because it involves all computer enumerations and there's no theoretical proof as of now. So this kind of things were done in recent research. So all these ideas will help you, like the proof of Fermat's last theorem by Andrew Wiles is another example of recent cracking of ancient problems. See, in recent times, like last 2 or 3 decades, lot many ancient problems were getting solved one by one, and we are on verge to solve the other good problem also called twin prime conjecture, which I will come later. Of course, geometry and number theory were the oldest branches of mathematics, but still they are very vibrant. About number theory, I had said enough to you. Geometry is another area where people, especially who want to pursue pure mathematics, will have so much of liking, because to understand the basic structure of objects that you deal with, you need geometry. And geometry has so many variations, like what we do in schools, what we teach, what we studied in schools, they're part of what is called Euclidean geometry. But the other thing that we do not know very much in research areas, what is called non-Euclidean geometry, which can be applied to study space science in astrophysics, astronomy, and other things. So if you want to apply mathematics to study such objects like astronomical things and other things, I think you should know definitely about non-Euclidean geometry. Now, what is about this non-Euclidean geometry? See, non-Euclidean geometry is something where you get, if you know that in a triangle upon 3 angles, if you add the 3 angles in a triangle, they add up to 180 degrees exactly. That is what is known to us, and that forms a part of the flat surfaces that we are doing. So if you draw a triangle in a flat surface, certainly the 3 angles would sum up to 180 degrees. So that comes under, this was proved in Euclid's book, Elements book, and this comes under Euclidean geometry. But in non-Euclidean geometry, you can construct triangles in general surfaces like a sphere or a torus or a donut or something, or a cylinder, for example, or in some special kind of surfaces that you have which have specific bending over all places. In such cases, I'm sure that in most of the ways, the angle sum would not add up to 180 degrees. The Pythagoras theorem saying that a square plus b square is equal to c square will become either less than c square or greater than c square in non-Euclidean geometry. So this kind of all things that we know in basic Euclidean geometry gets altered into different results in non-Euclidean geometry, which is what is very interesting in studying about non-Euclidean geometry. And people like Hilbert helped Einstein, Minkowski, Hilbert helped Einstein to come up with the special general relativity theory in 1915, which he published, using this ideas of spaces and curves and all those things. So once Einstein said, I owe a lot to mathematicians because without their ideas, I could not have done any relativity theory at all. So that kind of observation was made by Einstein, thanking other mathematicians who had given many, many inputs from non-Euclidean geometry in particular. So that is what I have written here. And geometry now discussed with curvature flows, curvature equations, minimal surfaces, geometric measure theory, relativity theory, special geometry, geometric scattering theory, and dynamics of the Riemannian and modulo spaces. The other research area in pure mathematics is mathematical logic and foundations. But there are plenty of things that I can tell you. Now, if you want to consider who had given this theory, who had proposed the axioms of a set, who has proposed the axioms, how these numbers themselves are constructed. See, to understand the basic structure of numbers itself is quite abstract because numbers are themselves very abstract. So I had been experiencing so many things like this. If I ask certain people that certain teachers, when I met them in a conference or a workshop or somewhere, I would ask them what is number one, what is number zero. Most of them could not come up with the right answer that they expect. So there's nothing like zero or one at all. It is our quantification to measure it. Zero could represent anything for us. Even it has applications and meanings to philosophical way and other possible ways. See, the understanding of a number is indeed very abstract, and it is specifically oriented. In what context you are talking, it gives that particular meaning. In other words, it has so much of meaning attached to it. So this kind of analysis and analyzing the the very basic idea, who gave the theorem, why this particular axiom is true. Because we don't prove axiom, we only prove theorems. Theorems require proof, whereas axioms don't require proof. That is what we were taught of. Now if you look at your group theory idea, we start with the definition that any non-empty set G induced with the binary operation star is said to be a group if so and so that four properties are satisfied, like closure, associative, identity element, and inverse, and all those things. Now, what is the logicians of previous time, like Cantor, Bertrand Russell, Kurt Gödel, these people question the very basic assumptions of axioms. Who did come up with this? Now, if you start with axiomatic approach, geometry itself begins with axioms. Like in Euclid's book, he could have mentioned a point is an object which has no part in it, which means zero dimension. Because if it's just a part, it could either have a length or a breadth or something. Now, if an object which has just a length is one dimension, an object which has both length and breadth is two dimension, all those things. So everything starts in mathematics with basic assumptions of what is called axioms or postulates or whatever it is. It is the idea of non-Euclidean geometry has emerged from Euclidean geometry by disproving or seeing the falsity of one of the axioms or postulates that Euclid proposed, apart from 23 basic axioms that he did in his work. So, if you want to study higher mathematics, you need some basic axiom. But who is going to discuss about the truth or falsity of those particular axioms? This is what is a basic question now that we are facing now. And the other thing that we talk about mathematical logic is checking whether a problem has a solution, and if it possesses a solution, how hard it is. And that question was very famously called P, whether is P is equal to NP. I will come up about that later. Because topology is study of surfaces and curves and how surfaces behave. That is called topology. It's a more general thing which doesn't have give importance to distances between points in the spaces. It doesn't care about in what distance the points are, but it concerns about the structure of the object that we concern. And topology is used in variety of ideas which I have listed here. You can go through later. Representation theory is the very hardest work that we have here. It combines all aspects like topology, combinatorics, and everything. It's more general. It concerns the study of symmetry in a very deeper way. And this representation theory has many great applications in subjects like discussing molecules in chemistry and other aspects also. The people were doing this. Coming to applied mathematics, the first thing that I want to see is combinatorics. We usually see combinatorics as art of counting without actual counting. So if you want to select a committee of people from a general gathering of group, how do I choose? So that kind of answers were provided in combinatorics. It's a clever way of counting schemes were provided in combinatorics. Now, there are many great results that have been proved by previous mathematicians also, but still there are many unsolved problems that were hanging on in combinatorics. So if you are very much interested in counting problems, you can opt for combinatorics and read the corresponding literature. In probability and statistics, the second topic that I want to choose, you can study Bayesian methods, statistical mechanics. You can use probability effectively to this. The idea of Bayesian theorem is very much used in many applications in engineering. In fact, I remember in one aspect that a ship was lost ship after a few years of searching were found using this Bayesian technique, and it was a very great achievement. And analysis of Markov chains, mathematical finance were involve this aspects. In particularly, if you go to Markov chain, and there's a new branch called what is called stochastic process, which requires probability, of course, which where the states are not fixed like the usual events. So if you study those aspects, you come to know more about this. Research in probability and statistics has applications in theoretical statistics, machine learning, mathematical biology, computer science, and other fields. It's one of very active area of research. Financial mathematics, other area where it has enormous applications to economics and other aspects of mathematics and science. In particular, this financial mathematics can be used to decide the call option and put option in share markets, and it also helps you to make statistical estimation methods for large data sets using matrix theory. And you see, there are many problems, practical problems that can be solved and understood in a better way, whether this is good option or not using financial mathematics. Mathematical biology, this is the other area, a new emerging area. See, once the structure of DNA was revealed after 1950s, I think it's 1952 by Crick and Watson, uh, people were coming out with various structures of biological nature, and today people, mathematicians have come to evade biology in very good way, and they construct more models and methods and introduce so many aspects in biology through mathematical models and give wonderful suggestions which helps biologists to decide whether this is good way of doing or not. As I said in the introduction, including controlling this pandemic situation, people were doing enormous research in mathematical biology, which is combination of mathematics and biological sciences. In fact, the mathematician who helped Ramanujan was G.H. Hardy. Without knowing its impact, he wrote just a paper about what is today it's called a Hardy-Weinberg principle, about how genes, basic type of genes, what they call alleles, separate themselves in a different way. It has quite wonderfully mixing with algebra, where you find expansions. Like if you want to expand a plus b plus c whole square, a plus b plus c plus d the whole square, and all those many number of variables to the power 2, the coefficients will correspondingly give the number of alleles to the number of variables that you take. So this kind of connection was made by Hardy as well as Weinberg, the physicist, and it is today famously called Hardy-Weinberg principle. You know, this has been the basic law of genetics right from the previous century, exactly from 100 years ago. So sometimes mathematicians does research without knowing their impact. Sometimes they knew the impact and they does research. This is one of the first kind. In scientific computing, of course, people used mathematics to study machine language, artificial intelligence, automata, formal languages. There are so much of things mainly concerned with computer science. This is what the scientific computing is concerned about. Mathematical physics is applying mathematics to study the structure in physics also. So if you want to know many ideas in like quantum mechanics, see, recently there are many papers that were coming up, uh, finding connection of prime number patterns with understanding quantum mechanics, statistical mechanics, astrophysics, and all these things can be done mathematically. So physics involve more mathematics. To understand physics in a deeper way, of course, you need mathematics. And the other miscellaneous research areas that I can propose, probably I think in my experience, is dynamical systems and differential equation. Dynamical system is a more general case, but a special case of dynamical system, you have what is called chaos theory and fractal geometry and all those things where you can program recursively a given process and then do using computers, you can come up with an idea and see how best your solution is. The other applications, information theory and signal processing, and then you can use mathematics to like all kinds of transforms like Gabor transform, Hilbert transform, and whatever available transforms techniques to use it to what is called digital image processing, compressed sensing in electronics and electrical engineering. And game theory, of course, another very good research area where you can have very good decision making strategies to people to solve many real life problems. Graph theory and networks is another very active research area. Operations research, of course, you know about this, so I don't want to mention more about that. Fuzzy logic is another research area. So these are my suggestions that people, if you want to pursue research apart from the main topic that I gave you, like the previous things, these are some kind of sub-disciplines that you can choose. Fast numerical algorithms, and then what you call recreational mathematics. Recreational mathematics has been done right from ancient time, but you can take up some good problems and then do research. Now, recently, some 10 years, a couple of weeks ago, a, a mathematician of aged 103 or so, Shivkandi, whose name is Shivkandi, passed away. In fact, we shared tribute about him also. What is He solved a problem in the creational mathematics which was printed in first page of New York Times. So he with other Indians from R.C. Bose and his research associate Parker came up with a solution for a 10 by 10 lattice square, which Euler's believed that it's not possible. Euler conjecture that the 10 by 10 Latin square would not be possible in his work. But later on, after nearly 300 years, in 1959 or so, they disproved Euler's idea that such a construction was possible. In fact, they came out with a very good proof that to construct such ideas, and many research aspects were carried out from that point of time. So in recreation mathematics also, you always have possibility of performing very good research. So these are the broad research areas. Of course, as I told earlier, you can always choose your own research ideas. Now, before closing out this session, I would, the next step, after identifying the problem, after choosing right guide and the problem and solving it, you need to publish your work. And this is where the other aspect of research is going on. Unless you publish in right journals and with high impact factor and other indexing, your work will not be recognized globally. So you can publish your journals in Scopus Index, Web of Science, IEEE, and other scientific indexed Sky journals. Also in UGC CAR Group 1, Group 2 indexed journal. There's a spelling mistake there. It's indexed journals. Scopus is indexed by Elsevier company in 4 categories: Q1, Q2, Q3, and Q4. Now, Q1 journals are the top 25% journals of publication in the whole world. Q2 journals come under the second quarter period, like 25% to 50%, and 50% to 75%. The third quartile is Q3, and the last quartile from 75% to 100% of the last 25% of the most active journals comes under Q4. See, most often, many great mathematicians have their published work in either in Q1 or Q2, not below that. So this is what, if your work is very great, you can go for publishing in Q1 and Q2. Whereas if your work is little bit lesser ideas involved, you can go for publishing in Q3 or in Q4. Now, Scopus Index journals are very credential, and if you are publishing more papers in Scopus, your research is very good there. And I have given the list of Scopus journals here, list of top mathematics journals with Scopus Index. You can, if you click this link, you can see that link, journals list. Out of 423 top Scopus journal in the link provided here, there from 1 to 99 were of Q1, 100 to 199 were of Q2, and all those things you can see. So it is categorized accordingly. Q1 journals comes first, Q2 next, 1/4 of the whole portion, all because it is roughly not exactly 1/4, it is somewhat more, less and more. Okay. So as of 2019, there are 39,744 Scopus Index journals in all disciplines, not just in mathematics. And I have given the download list, which is see, recent times it's not available at free, so I took some care in doing this. So those who are interested can download this and select possible mathematics journal. This number 39,744 is inclusive of all disciplines. The other index that you can go apart from for science people, the second possible index apart from Scopus is Web of Science collection. Web of Science is indexed in 4 ways. The core collection, what they call SCIE, Science Citation Index expansion or expanded, Social Sciences Citation Index SSCI, Arts and Humanities Citation Index AHCI, and Emerging Sources Citation Index ESCI. So these are 4 core collection that comes under Web of Science. But recently people were doing all kinds of research in various scientific subdisciplines. So the Web of Science has expanded this citation indices to 16 more citation indices, which you can see in the Web of Science portal by possibly logging in. The login is free, so you can create your own free login and then search. As an example, I submitted a recent paper, very recent, like last week or so, in the journal, Indian Journal of Natural Sciences, where I submitted an application paper of mathematics strategies to allocation of hospital beds, especially during this kind of treatment with pandemic issues. So that paper was accepted in this journal. So while I was checking whether it is indexed in Web of Science, this is what the result. You see Web of Science group here, So this is a portal of Web of Science. If you have login with you, you can just log in. Only if you log in, you can come to this. Type the journal name here, it will show. If the corresponding journal is indexed in that, you will get this box where the journal name will be published. Now, UGC has set up a new idea called CARE, which is Consortium for Academic and Research Ethics. Now, those who want to publish papers after 2019, like after say in October or July 2019, they should only publish in UGC CARE. Previous to June 2019, there are many UGC approved journals of previous time. There were even, I think it should be around 40,000 journals, UGC approved journals. But because of lot of things that has been copied and pasted in many journals in all the subjects, people want to have quality papers getting published. So they formed a committee, and the new committee named this kind of getting quality research papers published, and they restructured or modified the existing UGC journals to what is called UGC CAD journals now. So the UGC approval given to as many journals before were drastically reduced, and only UGC approval now is given for CAD journal to very quality journals who publish only original research. So as you can see, in almost all the UGC CAD journals, they have now the practice of getting plagiarism test, where if you submit a paper, they send the paper for plagiarism test through authorized software. Plagiarism test is a test which test your paper and see whether you had copied the content right from the definition, right from the abstract, whatever is, whether you had copied from some other source as it is. They allow each journal has their own level of accepting or rejection level, plagiarism level. Like some journals, Indian journals accept up to 30%. Some journal accept only up to 20%. But Scopus journals and Elsevier journals accept only less than 10% of original work. And that too, this plagiarism check was done for the first step. If the meaning that if you have lesser plagiarism level, that doesn't mean that your paper gets published. It was peer reviewed by at least 2 people in the respective journals of the editorial board, and only after their consent and their satisfaction with possible modifications and suggestions that they provide, your paper will be published. This is the usual practice to ensure the quality of good research. This is what is done in today's scenario. UGC CARE has divided the whole journals into 4 types. You can read them later. I don't want to discuss it here. And the list of UGC CARE journals in sciences, social sciences, arts and humanities, and multidisciplinary categories were given in the link provided to you. And the list of 39,111 UGC CAD journals can be seen at this link. This is a quite important link that for research students. So if you want to know whether, because there are many fake journals who claim that they have UGC approval, but they don't have. So to check and ensure whether a corresponding journal is of UGC CAD type, this is the first list is what is called group 1 journals. The second list of 39,000 and odd list is what is now called group 2 journals. So there are 2 groups of UGC CAD journals. If the corresponding journal that you publish comes under either the first link journal or the second link journal, it will be considered as a valid journal for publication. So as of now, you might be knowing that PhD students are compulsorily have to submit at least 2 or 3 research papers before they submit their thesis. So if you are going to submit your research papers for a dissertation or your thesis work, you have to publish in this UGC CAP. Don't do in other local journals which pretend to have all these things. So you have to choose corresponding journal and see if it is properly indexed and listed in this list. Okay, so that is one thing. And if you have any doubts, you can tell me. I can check and tell you, no problem. The top class unsolved problems are called millennium problems in mathematics. I just give the names, you can read it later on. Yang, Mills and Moss gap hypothesis, Riemann hypothesis, P versus NP problem, which I told about before in discussing about one of the branches, P versus NP. P stands for polynomial, NP stands for non-polynomial. So whether a problem can be solved in polynomial time or non-polynomial time, that's the question there. Riemann hypothesis is one of the, it's called the holy grail of all mathematics. It's concerned with so many big ideas, and thousands of theorems depends on the truth of Riemann hypothesis. So almost all mathematicians in the whole globe now seek to prove Riemann hypothesis, which was proposed by Riemann in the year 1859. Okay. So, and Navier-Stokes equation, another beautiful problem in differential equations, and it talks about the stability and the turbulence factor. So, if you are traveling in an airplane, you might hear the announcement that due to turbulent plane will shake, so wear your seat belts, all those things. So how kind of turbulence that you influence or you observe, and how do you rectify it? It was answered by Navier-Stokes equation. Hodge conjecture is a very deep conjecture concerned with algebraic geometry and other kind of algebraic equations and all those things, which is uh, identifying one structure with another structure, basically with topology and other things. Poincaré conjecture has been proved. So among these 7 millennium problems that were listed in the year 2000 by Clay Mathematical Institute, the sixth problem, Poincaré conjecture, was proved. In the year 2003, it was accepted. It was proved with a great effort by Gregory Perelman, the Russian mathematician. And that's a different story. So he was awarded a Fields Medal in the year 2006 in Madrid, ICM, but he rejected. He never went to the conference. He rejected that. And the last problem was Birch and Swinnerton-Dyer conjecture, which is again about some kind of differential equations and discussing the number theory, especially elliptic curves and other kind of equations. So these are very great problems. And at the end of this, I will have given many links, which is just about mathematical research ideas. So this links actually, if you go to this link, you find many good articles, many good papers that were available from great organizations like American Mathematical Society, Society of Industrial and Applied Mathematics, SIAM, and Cambridge University Press, and applied mathematics areas where people used to see IMA's Institute of Mathematics and Applications, which is very good in doing applied mathematics papers, and mathematical intelligence research paper that was very standard, good standard, Springer Company, Hindawi. So you can go to all this journal sites and find enormous number of work done by other mathematicians in the recent past years, which will give you a very good idea of how much research has been done. So it will be very useful for research scholars doing this. Finally, I will quote that Galileo's thing that laws of nature is written in the language of mathematics. Because of all these ideas, I mean, people were counting number of research papers that were done in mathematics. They counted nearly 20,000 results. Very, I mean, beautiful results coming out every year, year after year. At least 20,000 papers throughout the globe from various people working on. So research is, though it is in India, it's mandatory. As I told before, it helps you to redefine yourself to becoming a very good mathematician, a polished teacher, and all those things. So do research, but for beginners, those who want to do research, I mean, say for doing research in big institutes like IAC, IITs, and NITs, or other institutes where you get some grant and doing as a full-time scholar, is different because you get to have good exposure. But for basic level students and basic scholars who have to pursue a job and as well as do research in part-time or in other modes, I would suggest to take a simple problem. See, there are many simple problems that are available in all disciplines that I spoke. So don't go for taking this kind of big problems like what I told you. These are just for the sake of knowing what is what in the research. But you consult with a very simple problem with simple techniques. If somebody has done some research in with 2 cases, you try to extend them to 3 cases or 4 cases. You try to model it for the next possible level, and then finish your research. Put a paper in the index journals, as I told you, and then finish your research. After getting your degree, seeking your job, I mean, getting the things done with you, and getting that satisfaction with you, getting settlement, you can apply and research your ideas to going for attacking the deeper problem. And year by year, you come to know. I know people who are more than 80 years, at least half a dozen of them, even in India itself, who were very good in doing mathematics and research. In fact, they publish at least 2 to 3 papers a year, even at this age of 83 or 85 or 90 or even then. And there are many people who goes to the institute. They could have retired by 65 or 70, not more than that. But even then, they go to the research after 80 years or so. They go to the research institutes and sit there for some time, relishing their moments of period, and they guide students now for their research. They give advices to them, though they do not go every day. They go once a week or some specific time period and spend that time to guide young students. So this is because of the passion, the excitement that they had been doing research for all the number of years. So they were doing research for more than 50 years or 60 years or so. And the other thing is that if you are doing good research, there are more awards and other meritorious things that you can get. You identify yourself to be a very good teacher. You get the satisfaction of being good research mathematician. So with this I think choosing the problem is very vital thing, and consult many great professors. There are many good people to help you out, and even what little I know I can share with my ideas. So with this I think I can close out my session. I thank Prashant, the head HOD of this Little Flower College, and Raman and other people who are guiding me for doing this presentation. I will be happy to answer some questions, and if there's something else, you please tell me. Thank you.
Thank you, sir. Thank you very much for night's presentation, sir. Shall we go with the question answer session, sir? Queries? Shall we go with the query session, sir?
Yes, certainly.
Yeah. Now I request our colleague, Mr. Naveen Kumar, Department of Mathematics, to take over the session for the question and answers, query session. Over to Naveen, sir.
So one thing, I will share this presentation to the Little Flower College people. Those who require can get.
Sure, sure, sir. We will forward, sir.
Sir, if there are any questions, I can answer.
We will. 1 minute, sir.
Thank you, sir.
Yeah.
Am I audible, sir?
Yes.
Yeah, thank you. Thank you, Prashant, sir.
Yeah.
Sir, thank you very much, sir. Sivaraman, sir, for giving us a beautiful session, sir. It was very beautiful and very informative, sir.
I couldn't hear your voice clearly. Could Prashant or someone else can interpret me?
Yeah, sure, sir.
Yeah.
Naveen, sir, can you keep your microphone a little bit far, no? Little bit far.
Okay, sir. Now, can you hear me, sir?
Yes,
are you able to hear me?
Yes.
Yeah. Yeah. Thank you very much, sir, for your beautiful session, which was very.
Yes.
Yeah, it was very informative, sir. And the slides were very thought-provoking, and you have given a lot of information to the participants as well as for the research scholars.
A good amount of work before I present. That's because it should be useful to everyone.
Yeah, thank you very much, sir. Sir, shall we move on to this questionnaire session, sir?
Certainly. If there are questions, I will be happy to answer.
Yeah, obviously, sir. Thank you, sir. So the first question from the participants is, how can we combine geometry with differential equations, sir?
Geometry with differential equations.
Exactly, sir.
Okay. So see, geometry itself have diverse areas. Like as I told you, there are Euclidean and non-Euclidean geometries. So differential equation is something the next part of calculus. And if you want to study differential geometry, not the classical geometry, if you go for differential geometry, you can characterize through differential equation, like studying the curvature aspect of a surface, or the geodesic, the shortest possible arc. All these things are done through differential equation, which actually people study in MSc level also. So differential equations has been very widely used in studying about differential geometry. In classical geometry, the basic tools and ideas are itself are enough. But if you go for geometry of higher spaces, the things get more complex. In such cases, I think differential equation plays a very big role, in particularly for deciding whether a surface is a minimal surface or it's a ruled surface or something. You need to have differential equations, and to categorize even, like if it is of first category or second category or something, you need differential equations. So like people could have studied about all these things, in particularly deciding about finding geodesic of a surface, for example, require differential equation. So if you have some interest in differential geometry, study that and then apply differential equation to a particular aspect like what I told.
Okay, sir. So second question, sir. So how to identify the Scopus index related to the journal, sir? Because there are so many fake Scopus index numbers. Scopus index numbers, there are fake index numbers are available, then how to recognize and how to identify, sir?
See, if you log into scopus.com, www.scopus.com, if you
Yes,
log
sir.
in, as I told about Web of Science portal, no?
Yes,
Similarly,
sir.
there
Yes.
is a portal for Scopus. You just go to Google and type scopus.com and then type your journal name. Or else,
Okay.
if you have, I have the Scopus link to you. If you
Okay.
if you go to that link and there is a big Excel sheet because it contains nearly 39,000 journals list. So it should be a very long list for
Okay,
many
sir.
pages. So if you go to find a tab and then put your journal, the
Okay, sir.
removed journals are listed in red color. So red color journals will not show you. The recently
Okay.
removed journals, and if your name is not shown anywhere, then that means the journal that you are searching is not in index type. And the Q4 journals will be usually dynamic journals. Up to Q3, you don't have problem. Usually they don't remove. They
Okay.
usually remove or include new journal in Q4 type. So that's the thing. Usually the Springer journal and elsewhere, and all those high index journals will come in Q1 or Q2. It don't come below that. So,
Okay.
so you don't have to bother if you're publishing in Q1 and Q2. And if any student or people have some doubt in doing this, because I myself was a member of editorial board of some 3 or 4 Scopus Index journals as of now, and some Web of Science journals also.
Okay.
So I come to know all these ideas. If they want to verify this idea, they can mail to me. I will send my mail ID also. So
Definitely, sir.
they can
Sure. Sure.
confirm and get published. So I
Definitely,
can
sir.
also help them in giving tips to get how to modify the paper, how to write the references, how
Okay.
to reduce the plagiarism level by choosing keywords and all those things.
Okay, sir. Very nice, sir. Sir, one more question, sir. We'll go for the next one.
Right.
So, in what way the Google Citation Index and ResearchGate Citation Index help the person involved in the research work?
See, Google Scholar is usually
Yeah.
a citation given for open access journals. The journals published in 2 categories usually. One is
Okay.
print journal, the other one is online. The online version is called open access journals. In
Okay,
open
sir.
access journals, whatever paper you publish, if it is getting published, they actually is available in the net all the way. So if I have published a paper some 5 years or 6 years ago in open access journal, even now or even after 10 years, people can type the name to go to Google and type it and get the paper. Or if they know the volume number and issue number of the corresponding paper, they can just go to the archives section of the journal, corresponding journal, and they can extract because it is free. That is why people are charging. Some little small journals are charging because they want to maintain this online portal. So even after 10 years, if somebody is interested in getting my paper or someone's paper in the internet, they can get it. So that what they call now that some people are getting publishing charges for the article. Some people are
Okay, sir.
getting article project. Now, if you go for Google Scholar citation or some other citation, Scopus itself is a citation index. So if you go for Google Scholar, because we use Google search engine at the most, it is
Yes,
indexed
sir.
automatically. Whenever
Yes,
you
sir.
publish a Google Scholar paper, so you can create a Google Scholar in citation page for yourself, and if you and then with your verified email of your institute should give you a personal ID in the institute name. Like if you are in Anna University, for example, it will give you your name at annaunu.edu.in, something like that. So if you are in IIT Madras, your name at iitm.ac.in. So this kind of
Okay, sir.
affiliation is given to you should be given by the institute. They have to create that mail to you, and then you
Okay.
have to verify in that. So Google will verify you whether you belong to the department of the affiliated college or university. And then once it is verified, it will start listing your papers one after the other that you publish. That will give more visibility to your research work because people will, if you're possibly doing a research in particular area like solving, say, quadratic equation, just for an example. So once a student want to do a project in quadratic equation, they type solving quadratic equation, your paper will be coming first because it is cited
Yeah.
in the Google
Yeah.
citation.
Exactly. Exactly, sir.
So that's one of the things. You get more visibility. Your research work will be spread to more people. You get more citations because of that, which gives you more value. So what you call, you get more H index and you get more recognized. Not only you, your work will get more recognized. Because of that, your name will be spread throughout mathematics community. This is one of the big advantage.
Okay, sir. Sir, one more last question, sir. Uh, can you please suggest the university names where the research work is going on algebra, sir?
Research is going on algebra.
Yes, sir. Algebra, sir. Research work is going on algebra.
Yes, yes.
Yes, sir.
No, I couldn't get. Research work is going on algebra. Then
yeah, sir. University names, sir. Can you suggest the university names where the research work is going on algebra, sir?
Algebra. So what's your question exactly?
So in that algebra here, how can we find the applications of number theory, sir? Journals in that
As
one.
I told you just before sometime in my talk, if you are a researcher, quite accomplished researcher, you find no difference between algebra, number theory, and geometry and all those things.
Yes,
So what you find is everything differs only at lower level. If you come to very high level, almost all research area combined together. For example, a person doing research in topology need algebra. A person who does research in number theory need geometry.
Yes,
So
sir.
many geometry questions were answered by number theory. Many number theory questions were answered with algebra. Many questions in algebra are answered by topology. We find this basic differences only for our classification of subjects in different things, and you need to assign different teachers. One teacher cannot take all the subjects.
Exactly, sir.
Of course. So only for giving more options to the teaching level, you classify their names as subjects. But once you go for research level, especially at higher levels, with some training with you, you don't find much difference between them. You have to mix all your ideas. So answer particularly to your question. See, you can apply ideas of extension fields and the finite fields ideas to come out with answering number theory questions like Diophantine analysis that I told you. That's one of the branches of the theory. So if I want to find, as an example I give you, if I want to find solution to the equation x squared plus y cubed is equal to 5, say mod 11 or something, mod 11, where x and y are integers, mod 11. So this kind of things were answered using algebra. In fact, you can also have studied that the famous theorem, like a power p is congruent to mod p, is done through algebra. You could have remembered as a corollary to Lagrange's theorem.
Yes, sir.
So you find lots and lots of applications of algebra, very basic things, as well as some more bigger things also. So what you can do is, if somebody has done a research in algebra with, say, rings, you can extend that to fields. Or if somebody has done a research in vector spaces, you can extend that to particular subspace of having some particular character. So that kind of ideas that you can do. It's all about thinking, spending more time on it, and working out. Sometimes you may succeed with your work, sometimes you may not. So you have to get the patience and try out with new ideas. That is a basic idea on doing research. You have to get the patience, and there are lots of applications of algebra to number theory, as well as the other way also. Applications of number theory to algebra.
Yeah, thank you very much, sir. So I request all the participants, because of this time constraint here, all the questions.
I can answer one or two more questions if there are interesting questions to me.
Okay, sir. Yes, yes, sir. Yes, sir. Yeah, what are the applications of this representation theory, sir? One of the participant is asking.
Yes, representation theory is a very new area, I mean, see, people like Grothendieck and other great mathematicians started realizing that all these basic structures, like can you identify a triangle with a cylinder? Or they equal? If you ask a school student, they may say it is not so. If I give you a rectangular sheet of paper, and if I give a cylinder object, small student of young age may say they're different, very, very different. But what happened if you roll the rectangle side by side, like this, with say their bit joining together, like a rolling the paper, either lengthwise or breadthwise, you get a cylindrical object, hollow cylinder. That's what you get. And if you join those ends of a cylinder, you get roughly a structure like a cycle tube. And that is actually called torus shape in differential geometry, donut shape. So a rectangular sheet of paper, which is basically two dimension, can be folded in a proper way to get a particular object in 3 dimension. So representation theory actually answers says, or topology in general says that these two objects are identical. They are topologically same, but they are not same in metric spaces or with respect to real analysis. In lower dimension, or if you talk about dimension, they are not equal. But with, representation theory and higher algebraic topology, like this kind of things, never consider about dimension because they are not bothered about distance factors. If you have an object A, you can do some operations with it, like extend it, pull it, like a rubber sheet. You can pull a rubber band, stretch it, or shrink it, or you can rotate it, or you can move it, translate it to some way, or you can do some kind of operation to get another object B. If you do this kind of possible operations from A to get B, then I can say by representation theory that A is represented by B, as well as you can get B from to can get back A from B the other way also. So this kind of things is what is required, and representation theory analyzes these facts. Now, how do we apply these ideas? See, people are doing vast amount of research in black holes. Last year, uh, the, the front portal of black hole picture was released by April last year. It was the first photograph of black hole, but it was not the whole black hole itself. It is just the rim of black hole that is very very bright orange color. Now, what happened was people now investigated and research had been carried out with identified that two black holes can merge at a point, which is what Einstein said through his mathematical equations. So what people realized that if one thing can be merged into other, they are topologically equal. So Einstein conjectured or suggested that there are two black holes in possibly in different sizes. They can merge to become a single black hole. People were very hard to anticipated through representation.
Yes.
Representation theory answers this, but to get the experimental evidence, you need to go to the physicist and do this experiments. You can't do that in a paper.
Yes, sir. The questions are over, sir. Almost all the questions have been completed, sir. And thank you very much, sir. Now over to Prashant, sir.
Thank you, Naveen sir, for a nice session, and thank you, Sivaraman sir. Hope the session was excellent, sir. Even so many faculty, research scholars, students are posting that excellent session. They have seen the like PPTs also, the good information they got. Those are the research scholar also, different scope and where they have to upload and how to.
My last advice to them, if they need any assistance, your people or some other people, they can write to me anytime. Maybe sometimes because of my busy schedule, I might answer the next day or.
Yeah, definitely, that's what, sir.
But anyway, I will surely reply to every concerned inquiry.
Sure, sir.
Yeah,
definitely sure, sir.
Yeah. Now, small request to all participants. Still, you have any queries? We'll provide SAR mail ID also. Can you post your question to SAR mail ID so SAR can address you your queries also? And one more thing is, all participants, please fill the feedback form, and your certificates will be sent to your respective mail IDs within a week. Once again, I'm repeating, all of you, please fill your feedback form, and
I thank for this wonderful opportunity to address research scholars. Yeah. I hope it is useful, at least in some way.
100% useful, sir. Now we'll go to. Now I request our colleague, Mr. Naveen Kumar, to propose out of thanks, sir. Over to Naveen, sir.
Yes, sir. Thank you, sir. Yeah. Thank you, sir, for your beautiful session. The slides in the session were thought-provoking and were very informative to the participants as well as for the research scholars. On behalf of the Department of Mathematics and on my own behalf, I extend heartfelt gratitude to Dr. R. Sivaraman, sir, for enhancing us in the area of research in mathematics and sparing his precious and valuable time for the webinar. In this session, the sir has enlightened us on the various branches of research work which are available in the mathematics by giving us information with various methods. In addition to this, sir has focused on algebra, analytical geometry, in which the geometry of modulo space curves, Gromov-Witten theory, and of course the analysis and the differential equations, and also number theory, in which the sir has given the importance of the numbers and also gave the significance of 28 as a perfect number, and of course the geometry in which the Ricci and mean curvature flows, which are the prominent areas of the research work. Last but not the least, the representation theory, how it is going to work and its applications in the various fields of the science, which were very informative and useful for the research scholars in their concerned field. Lastly, the sir has given us various groups which are existing in publishing the journals in the concerned site. I thank our college management, Principal Reverend Brother Vincent Reddy and Vice Principal Mrs. Jayanti Reddy for encouraging us and giving the constant support for conducting this webinar. A special thanks to Mr. Vijay Kumar and Mr. Raman faculty from the Department of Computer Science for their technical support in the webinar. I also thank our staff, faculty, and the students of LFDC for the coordination and the cooperation in all aspects in the webinar. Last but not the least, I would like to thank all the participants from the various institutions and the research scholars from the various universities for attending this webinar and making this as a grand success. And with this participation, it had got an importance, and without you, it was nothing. Thank you, one and all. Stay home and stay safe. Over to Prashant, sir.
Thank you very much, sir. Once again, I'm very thankful to Dr. Sivaraman, sir. We asked him, immediately accepted to present such a beautiful session for all research scholars, faculty, and students. It was more informative, sir, for us, and not only for us, for others also. Once again, on behalf of me, our department, on behalf of our college, will gratitude to you, sir. Thank you
I
very
would
much.
be happy to extend my help further also, depending upon.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you.
So just I request the participants here, if any participants are having the queries, you can just please post to our mail ID lfdcmathsdepartment@gmail.com, which is provided in the chat box. Just you can post your queries. Thank you.
1 minute, sir. Sivaraman, sir.
Yes.
One participant asked about Pi Association. Can you?
Yes, I was saying this.
Yeah.
See, Pi Association, as you know, is a mathematical association which is registered as a trust for dispelling math phobia, which usually occurs at the level of high school level. See, I always wonder that people up to 5th class will enjoy mathematics because they were taught mathematics by using objects and visible things. But once they come to learn about negative numbers and algebra and other things, they start fearing. So this kind of things, we develop so many models from that level, from primary level to postgraduate level, to teach those concepts through a visual way. So that's one of the thing that we have been doing, and we publish so many books to as application of mathematics ideas to various things. Like we have written 2 or 3 books regarding how mathematics related to stories, both mythological as well as scientific stories. To say, in one book, I recently wrote Cracking Crimes in English, which is about applying mathematics to solve crimes, like in Sherlock Holmes type or something. And in another book, it is applied to solving various problems in engineering and science. That is called Journey of Genius, and all those things. So this kind of all kind of possible ways that our association is doing to remove math phobia, and I'm grateful for my students, former students, who helped me in doing this very effectively for the past 13 years.
Thank you, sir.
So those who wish to know about further about this, they can go to Google and type. We have our Facebook page also. We have our website, so they can see further.
Sure, sir. Thank you, sir, once again.
Thank you, sir. Thank you.
All participants will get certificates within a week to your respective mail IDs. You don't worry about the certificate. The only thing is, all of you please fill the feedback form within a stipulated time. Today only. So my request to all participants, please fill the feedback form, and we will send your e-certificates to your mail IDs within a week. Thank you once again. Stay home, stay safe. Thank you, sir.
Thank you, sir.
Thank you, sir. Welcome.